We would like to know if this series converge or diverge. Sigma when n goes from 1 to infinity, ln of n squared plus 1 all over 2n squared plus 1. And this right here is pretty complicated, isn't it? But then we should always have a habit. Let's just look at this expression and take n to infinity to see what happens. Because remember, we only need to do more work if we end up with 0. Because if the limit of this, if it is not 0, we are done. We can conclude that this series diverge. So let's go ahead and do the check. That's the test for divergence check. As n goes to infinity, I will just write down this expression right here, which is ln of n squared plus 1 over 2n squared plus 1. Well, let's do this inside out. The inside we have n squared plus 1 over 2n squared plus 1. On the numerator, only n squared matter. On the denominator, only 2n squared matter, right? So this right here, we approach to ln of n squared over 2n squared. And as we can see, the n squared will cancel each other out. And therefore, we know this will be ln of 1/2, which is not equal to 0. This is certainly not equal to 0. Only ln 1 is 0. Therefore, as you can see, this does not approach to 0, right? The sequence-wise, right? This right here, this formula-wise, okay? So, the whole series diverges. We know this right here. Diverges, and I can quote reason by test for divergence, which is you run through the limit check. And if, as long as we don't get 0, that's a good case, because you can just put down the series diverges and then you can quote by test of for divergence. And this is it.